Okay, today we are going to do the experiment number 19, that is synthesis of acetylsalicylic acid, the active ingredient of aspirin, that is a one analgesic or the painkiller. Okay, there are two parts in this experiment number 19. This is part 1, that is synthesis and purification of acetylsalicylic acid is part 1. In part 2 you will be doing the TLC of some analgesics there. So let's talk about the first part, that is preparation of or synthesis of acetylsalicylic acid. And this acetylsalicylic acid, which is an active ingredient of aspirin, is prepared by the reaction between salicylic acid and acetic anhydride. Okay, this is the reaction that I have shown here in the board. Now here, this reaction is actually the esterification reaction between the OH group of acetylsalicylic acid and the acetic anhydride group. That is where the acetylation happens, all right, and will form the ester. All right, so here with the O that is reacting with the CS3CO group here, that is where the acetylation will take place. And here about the acetic anhydride, sometimes students feel the difficulty in writing the formula of that. So remember the formula of acetic acid, and 2 molecules of acetic acid, when you remove the water molecule H2O from there, that is how the acetic anhydride is formed. This acetyl group connected with oxygen, that is acetic anhydride. So these are the 2 compounds that we are reacting. Now let us proceed to the lab bench for the reactions. And you need to know the mechanism of these reactions as well. That is what we discussed in the pre-lab discussion, how to carry out the mechanism for this reaction. Okay, we carry out this reaction in a small Erlenmeyer flask. So this is 150 milliliter Erlenmeyer flask, and we use approximately 1 gram of salicylic acid. I have weighed the salicylic acid here in the weighing board. It is 1.001 gram, that I have recorded the mass here, so you can take a note on that, 1.001 gram. So this salicylic acid I will use here in this Erlenmeyer flask first. Okay. Okay, this is salicylic acid, and the acetic anhydride and the phosphoric acid, we get that in the fume hood because we don't want to expose that in the atmosphere here. I need to add 2 milliliter of acetic anhydride, this acetic anhydride. So in order to take this 2 milliliter of acetic anhydride, I use this pipette to take 2 milliliter. Here is the mixture of salicylic acid with 2 milliliter of acetic anhydride. Now I need to add this, the reaction takes place in acidic condition, so I need to add 5 drops of phosphoric acid. So I will add 5 drops of phosphoric acid here. 1, 2, 3, 4, 5. Okay, 5 drops of phosphoric acid. And I need to swirl this reaction very well so that this will give little bit of heat here, and as the reaction is exothermic, so this needs to be swirled for some time here, and we can cap it with the stopper there. Okay, so here there is a cap for that, and we can swirl it for some times. And in order to complete the reaction, this mixture can be heated a little bit, slightly heated in the hot water bath for about 10 to 15 minutes in the hot water bath. So just let me swirl it for some time so that the reaction proceeds well, and that can be kept in the hot water bath there. So the water bath is heated at the temperature of around 70 degree here. So that is where I will put this mixture of the reaction here in the water bath. So it has been almost 5 minutes on the hot water bath, and see, this is forming a clear solution. Now we need to cool that in the ice bath. So we need to chill this in the ice bath. Here I have prepared the ice bath for that. So I will cool this, and now in this ice bath here we have formed the solid white substance there. Now in order to precipitate more, we will use this ice cold water, okay, 10 milliliter, okay, and also there is 6 gram of ice. That is what I will add to this reaction mixer, or the acetylsalicylic acid that's prepared, and we'll just break this ice there, okay, so that you will have enough product there. Very nice white precipitate is forming here, okay. There we go. This is acetylsalicylic acid. Now we need to separate this product by doing the filtration. You all are familiar with the vacuum filtration using the Buchner flask. So I use this small filter paper and make it wet by using some distilled water. Let it stick here on the surface, and I will use this hose so that I can secure that here. Now this solid we will collect by using this vacuum filtration using Buchner flask. So I have secured the flask in the utility clamp, and it's ready to run the vacuum filtration here. I have set up the small filter paper there, and it's completely set, okay. So this is what I will pour that here. And I have some product left on this Erlenmeyer flask. So in order to get that out, I will use little bit of this ice cold water, little bit in the beginning, so that I can rinse all the product that is set here. So that I will pour it here, okay. All right. Now we can wash this acetylsalicylic acid using a little bit of more cold water. It's just the washing, making it more pure. Okay. Here we have got very good amount of acetylsalicylic acid, and it is pretty much dry. So I will turn off the water, and here we have very good amount of acetylsalicylic acid. Now this compound, this product that we have here, needs to be recrystallized, and this can be recrystallized by using the solvent ethanol. So what we need to do is we will transfer this solid in a very small tiny Erlenmeyer flask. We will transfer this here, and we will dissolve in about 1.5 milliliter of ethanol, making it heat on the onset of this hot plate, okay. Okay, the product is, I have transferred in this Erlenmeyer flask, and I will use about 1.5 milliliter of ethanol to dissolve this. Now since it is not dissolved, I can make it warm somewhat here in the hot plate just by heating it to some extent. So in hot ethanol it should dissolve. The aspirin is completely dissolved and is a very clear solution in even 1.5 milliliter of ethanol. So we don't need to do any filtration or anything in this one because there is no solid particle anyway. Alright, now we need to recrystallize this by using water as the co-solvent here. So I have here hot water heated to about 55 degrees Celsius. This is the 10 milliliter of hot water. So that is what I will be using on this one, and I will add this water here. Okay, so this is the with water. Now we let it sit for 10 to 15 minutes. That is when all the acetylsalicylic acid will crystallize out from there. Let it sit here. Okay, recrystallization process, we have cool our solution in the ice bath, and we have got good amount of the recrystallized acetylsalicylic acid. You can see that. Now we can separate this by doing the vacuum filtration again, as we did previously. So let us set up the vacuum filtration. I use this small filter paper as before, so that needs to be set properly in the Buchner funnel, and here. So again, it's already set up here, so I can add the water, and this product needs to pour here. Then a little bit of ice cold water to rinse our product. Right. Okay, here with very good amount of dry sample of acetylsalicylic acid. Is a very crystalline also. It's like a very shiny crystals you can see there. Now we will find the mass of the product, and we also will determine the melting point and the IR and NMR of this product. Okay. Here we have got the mass of the product is 0.580 gram. Now we need to make the determine the melting point of this. So we use this capillary tube to load this substance there. So the capillary tube loaded with the sample. Now we determine the melting point here. I'll just plug in there and turn it on, and here is the thermometer that is already on, and the Celsius, so we put on the slot, and we will wait for the sample to melt. And now the sample has melted. The melting point is 131 to 132 degrees Celsius. So that is the melting point of the sample. Okay. So please record here the mass of the product, 0.580 gram, and the melting point is 131 to 132 degrees Celsius. That is what we find out for this aspirin, recrystallized aspirin sample. Here is the product mass is 0.580 gram, and the melting point is 131 to 132 degrees Celsius for this pure acetylsalicylic acid or recrystallized acetylsalicylic acid sample. And we needed to characterize that by using the NMR and IR, and we already determined the melting point of that. Now for NMR, I already prepared the sample there in CdCl3. I used this deuterated chloroform as the solvent. I prepared the sample, and then I recorded the NMR here. So this is the NMR of acetylsalicylic acid in deuterated chloroform as the solvent. So you needed to characterize that all the peaks that is necessary there. Okay, so I will just give the printout here. Okay, so that is the here. So I will just give the printout, and you will have this in your D12 also. It will be printed there. Okay? Now here we are for the IR of the starting salicylic acid and the product, this acetylsalicylic acid, so that we can make the comparison. So here is the IR of the starting material salicylic acid, and you need to label the key peaks from this starting material. Again, I will upload the printout of this in your D12 so that you can characterize the important peaks, and we will have now the IR of this product so that you will make the comparison of the peaks on the starting material and the product. So here is the IR of the final product, acetylsalicylic acid, and again I will upload the printout of this IR in your D12. You need to put them together in your lab report, make a good comparison and explain about what are the peaks, key peaks, and how you identify that. Okay.